Hello again and welcome to a new episode about making stuff on your CNC using FreeCAD. And by making, I mean making the 3D model, then generating the G-code and moving on to the CNC to do the actual milling. Just make sure you're not missing any steps, and I can guarantee you that at the end of this video you'll be able to go to your CNC and mill the model that you wanted to mill for a long time using only FreeCAD. So watch the entire video and you will learn to do a lot of stuff. We will make this very nice tray which has pockets, has sloped pockets, has inlays, which is kind of complicated if you don't know some little tricks that I will show you today. But before moving on to the making of, let me take a break and talk to you about the sponsors. It's about you. It's about the ones that watch my videos, the one that like them, that comment on them. Thank you very much. You are a great help for me for watching, liking, commenting and even sharing my videos. And of course, if you want to give me a little financial help, subscribe to my Patreon account. And on that Patreon account you will find two products, a thanks and a big thanks, which you can buy one time if you like this video and want to help me. Let's move on to designing our tray. I'm using FreeCAD 0.22. Let's start in the part design workbench. First create a new body. This will be our tray, so right click on it, go down to rename or press F2. Let's call it tray base. And we need to draw a sketch which will be the shape of the tray. So let's create a new sketch on the XY plane. And I will draw the outline of the tray. It will be a rounded rectangle. Select the origin, drag it, and let's enter some dimensions. I usually base my dimensions of the stock that I have. So now I can create a tray of 350 millimeters by 250 millimeters wide. And now I have to give it a radius, which will be a radius of 50 millimeters. So we have the shape of the tray. After closing the sketch, I will pad the sketch for 33 millimeters. It's the thickness of the stock that I have. And now we need to make the inside of the tray. We will do that using a Subtractive Loft using two sketches. So let's draw the first sketch, still on the XY plane. Press this button to view a section to hide everything up to the face of the sketch. Draw a rectangle. This time I won't start in the origin, but somewhere around here. And I want this to be offset 1 centimeter 10 millimeters from the outer edge of the tray, so I will select this point, press on L to give it a length 10 millimeters. Do the same for the bottom line. Select this point here, press on I this time for height, give it a value of 10 millimeters. And I want to offset this from this line, the same on the right. I can do this two ways. I can either calculate in my mind the total height and length of this rectangle, and this is the way I will go, but I could also use external geometry. I prefer to avoid using external geometry because even though I'm using 0.22, which officially has the topological naming problem solved, it still has some bugs, so I will use the safe way. Select the bottom point, the top point, press I between them. Since I had a tray of 250 millimeters, I want to subtract 10 millimeters from the bottom and 10 from the top, so I will give it a value of 230 millimeters. And do the same for the horizontal. Select the point that we have already offset from the y-axis, select the other point and press L for a length 330 millimeters. And we also need to give this a radius. Select any of the rounded corners, press KS to insert a radius. I'm not very sure for the new shortcuts. It used to be R, now it's K, then followed by S. And I will give it a radius of 40 millimeters, which will result in a consistent thickness around. So now the sketch is fully constrained. You can see it is all green. You can also see here in the solver messages it is fully constrained. Close the sketch and let's create a new sketch, still on the XY plane. Let's do the exact same thing, hide everything up to the sketch, draw a rounded rectangle. And now let's position it. I want it to have a sloped side, so I want the inside rectangle to be smaller than the outside. Let's do the same thing as we did for the previous rectangle. Give it a length of 20 millimeters. I want a slope of 10 millimeters. Also here a height of 20 millimeters. Now select the bottom and the top line. Press I again to set a vertical distance between these 2 points. Whenever you select just one point, it will set the distance from the axis depending on horizontal or vertical. If you select 2 points, points, it will set the vertical distance between the 2 points. I have 20 millimeters on the bottom, 20 on the top, and I want to subtract those two values from the 250, the total width of the tray, so it will be 210 millimeters. Now let's do the same for the horizontal. L for length, 310 millimeters, and let's set also a radius. Press KS, and we will give it a radius of 30 millimeters. I will now close this sketch too, and if I take a look, I can see that both the sketches are on the bottom of the tray. So let's take the first one, the outer ring, and let's raise it to the top of the tray. So go to attachment, offset, position, and change Z to 33 millimeters, which is the total height of the tray. For the second one, I will only raise it up to the bottom of the inside of the tray. I want it to be 20 millimeters deep, so I will raise it 13 millimeters. Now let's select the first sketch, holding Ctrl down, select the second sketch, and click on this button, Subtractive Loft. Click on OK, and you can see the shape of the tray. We still need to make the side cuts for the handles, so for this I will rotate the view, select this face, and create a new sketch. This isn't really safe because you might run into the topological naming problem later on if you decide to modify something, but I don't plan on modifying anything for now, and it's okay to place the sketch on the face. If I wanted to make this tray completely modifiable, I would use a separate spreadsheet for all the dimensions, but for now let's leave it as is. It is adapted to the stock that I have and to what I want to do. So select the side face, press on the sketch button, and I will draw a simple rectangle this time. I won't draw a rounded rectangle because it will leave some unwanted material on the bottom. Randomly draw it again, and I will give it a length of 150 millimeters and a height of 25 millimeters. It's the height of the handles. Now we still need to place it. Select one of the bottom corners, press I, and give it a value of 0. Let's also move it to the left, so select the same corner, press on L. We will set a horizontal distance, and because it is the distance from the origin, from the vertical sketch axis, it has a negative value. So I will give it a negative value of -50, and now it is centered correctly. But I still want to make the two top corners rounded. So I will go here to the toolbar, select the Create Fillet tool, click on the first line, click on the second one, do the same for the other corner. I need to constrain these two curves, select them both and press E for equal. I will make them equal. Let's give them a radius, press K and then S. I will use a cutter head with a diameter of 15.9 millimeters, so I will give it a radius of 7.95 millimeters. And now everything is defined. I can close this sketch, and I will make a pocket of 15 millimeters. Now I have the handle on this side, but I have run into a problem. The cut will go all the way through the material, so I will make this cutout a little bit smaller. Go to the pocket, click on the arrow next to it, double click on the sketch, and let's change this height from 25 to 20. Close the sketch, and now everything seems okay. And I want such a pocket also on this side. I have a lot of options for this, but the easiest for me right now is to simply draw another sketch on this face, do exactly the same as I did in the first one, and the sketch is ready. I can now close it, make a pocket of 15 millimeters. So this seems the easiest way when designing one-time use models. Now that we have the shape of the tray ready, we still need to make the inlay, and for that I'm going to use an SVG. I will go to File, Import, select the basketball file, and I will choose here SVG as geometry. Click on open, and you can see the basketball here imported as a bunch of paths. So now we need to change the workbench. As I've told you, we are using a lot of workbenches. I will go to the draft workbench this time. The first thing that I do is press G then R to hide that annoying grid. Select all the paths that have been created for the basketball and press this button, draft to sketch. I can now delete the imported elements, and I have a sketch which seems, let's set a top view, seems a little too big for the tray that we are using. So I will select the sketch, go to this tool which is scale, select any corner, and now I can modify the X, Y, and Z factor. It has uniform scaling checked, so whichever of them I will modify, the others will modify too. I will give a value of 0.65. You can see it here smaller. Click OK, and again I want to refer to the material that I have. For the inlay I have a piece of material which is 110 millimeters wide. So now let's hide the larger sketch, and for this sketch I want to know if it fits on a 110 millimeters wide board. The easiest way to do that, select it, go to the view in the bottom and change the bounding box from false to true, and I can see it has the dimensions of 137 by 137, so it's a little too big for my material. I will delete this sketch and press space to make the original visible, because I don't want to try different values until I get what I want. I will select this sketch, go to the view, change the bounding box from false to true, and I can see it is 211 millimeters. So if I want to get 110 millimeters, let's do a simple calculation here. 110 divided by 211.88. I have a ratio of 0.5191. I will use 0.5, it's a round value. So select the sketch, go to scale, select whatever point from this and write the factor 0.5. You can see they have all modified because uniform scaling is checked. Click on OK. Hide the larger scale, also set its bounding box to false, because no matter if it's visible or not, if you set the bounding box to true, it will show the bounding box. Let's double check for the reduced size sketch that the dimensions fit on my small pieces. It's 105.79. it will fit on my darker wood board of 110 millimeters. So now we need to move this sketch and position it here. I will drag it into the body, into the tray base, and go back to the data tab, go to map mode and click on the three dots next to deactivated. Make sure selecting is pressed, it's blue, and select this face. Click on OK, and we still need to move it. Select it, go to attachment offset, position, change the X to move it to the right and the Y to move it upwards. Hold Ctrl down to multiply by 10 the steps. Now let's set the top view and to arrange it, and now you can see there's a bug in the display. If I'm having a perfectly top view, I won't see the lines, but I rotate it a little bit and it's okay. And now I have the sketch correctly positioned. I can select it, go back to the view and change the bounding box to false. We will use this sketch to make an inlay. So we want a cutout. I will go back to the part design workbench, select the sketch and make a pocket. I'm going to make it 3 millimeters. Press on OK, and you can see the final shape of the tray. Here we will cut another piece of wood and we will glue them together, then flatten everything, and we will get that very nice tray that I've shown you in the start of the video. Let's move this sketch to the tray base also, so they are all grouped together, because even though it's the bigger sketch, I cannot delete it. You can see if I press delete, it will warn me that the clone that we have resized is going to be damaged. So click no, don't delete it, just move it to the tray base so you can have everything together. I will create a new body, press F2 to rename it, insert. This will be the other piece of wood that we are going to cut. Create a new sketch on the XY plane. Click on the view section button to hide everything up to the face of the sketch so we can see easily the sketch. Create a rectangle. As I've told you, it's 110 millimeters by 110 millimeters. I will change the length. I will make it 150 because my piece of wood is a little bit longer, so I can make a wider cutout on the sides. Click on close. The material is 8 millimeters thick, so I will make a pad of 8 millimeters. And now I want to place it on the recessed face of the basketball. Because it's still a development version, the measuring tool is kind of messed up, so I prefer to calculate this. I have a height of 13 millimeters for this face. It's the height at which the second sketch that we have used for the Subtractive Loft is, and since the pocket is 3 millimeters deep, it means that these recessed faces are at 10 millimeters. So let's select the insert, go to placement, position, and change the Z to 10 millimeters. Now let's move it in the correct position. I will set the top view, go change the X, then the Y. I will set an orthographic view this time. No piece of the sketch of the basketball is going out of the body, so everything should be okay now. I will select the tray base and click on the little sheep, the clone button, rename it so I know what this body is about. It's a tray base clone. I will go to the part workbench, select the insert, hold Ctrl down and select the tray base clone. Press on this button, make a cut. And now if I hide the tray base, rotate the view, I can see the shape of the basketball on the other piece of the wood. So I will select this cut, press F2, insert, Cutout. I will rename it so I know what I'm talking about. Let's make the tray base visible too. Here we will run into a problem. If I hide the insert cutout and take a top look at the basketball, you can see these corners here. The cutter head being a simple round end mill, no matter how small it is, it will have a small round over here, and I have to copy that exact round over on the insert, otherwise this will be cut with a straight corner and won't fit in the tray base. So how do I do that? Let's rotate the view again. I will hide the insert cutout. I will select them one by one, hold the control key down, and let's start with just this shape. Press the fillet button and I will give it a radius of 1.59 millimeters, which is half the diameter of the tool bit that I will be using, 1/8 of an inch, 3.175 millimeters. Click on OK and you can see that these corners are now rounded. I will double click the fillet and click on select and add the following shapes. Select the corners one by one. Click on preview from time to time to make sure everything is okay. It sometimes throws some errors and you have to make sure you know where the error is. Click on select again and continue to do the selection to the end. Now after adding all these edges, I have roundovers for all the sharp corners, which will result in matching shapes both on the tray and on the insert. So this is all I had to do to make the shape of this tray. Now we can move on to the fourth workbench, to the CAM workbench, and start making the G-code for the CNC. So select the tray base, click on the new job button, make sure the tray base is selected, click on OK, and now let's make some settings. Go to output, make sure the processor is the correct one for your machine. Mine is GRBL, so it's okay. Go to the setup tab. The origin and the placement of the tray is correct, so I don't need to modify anything here. Let's go to the tools menu, click on add, and I will add a 15.9 bull nose. I will use this to make the most of the cutout because it's a larger bit. Click on the default to remove it. Now let's give some speed. I will use 3000. Depending on your machine, you may use higher or lower numbers. A spindle speed of 18,500. Go back to the setup tab, open default values from the bottom. I want to use a step down of 2 millimeters because my panel is some cracked oak, so a lower step down will produce better results. So I will delete the op tool diameter value from here and simply write 2. Also modify the clearance and the safe height depending on the clamps that you are using. And that's basically all I need to do for now. In the job setup I can click OK. Of course you can use templates, it's much faster. If you want to know how to easily create templates, watch this video about creating job templates. It will make everything much faster whenever creating a job, and in just a couple of clicks you will have the job created. Otherwise you will have to modify all the parameters all the time. So now I want to mill this entire piece of the wood. I will select this face and select the face operation, and I need to change a few parameters here. The boundary shape I will set it to face region, the pattern to zigzag offset to clear the outlines after removing most of the material. I will set the angle to 0 to have a movement along the x-axis, and the step over percent I will increase it to 80%. It's enough for removing material. And after clicking apply, you can see that the facing operation ignores the inside surfaces. So this is what I want to do. I want to mill everything up to this face, including the regions here. If I have used the pocket operation, the area of the basketball would have been ignored, which is something that I don't want. The next step is to mill all these beveled edges. Disable the mill face operation so you can see better. Double click on the job, go to the tools menu, and I will add a 6 millimeters end mill, which I will use for making this beveled edge. Give it speeds 3000 also for the horizontal and vertical, the same spindle speed. Click on OK, and now select all these faces, the beveled faces, holding control down, and create a 3D surface operation. Select the tool controller, the 6 millimeters, click on apply, and it will take some time to compute this operation. Not a very long time for now, because we have to make some changes. As you can see, it mills also this part of the tray, which is time consuming. It's a lot of air time. For other operations in 0.22 I have an option, use rest machining, which avoids cutting where it has already been cut by the previous operations, but the 3D surface operation doesn't have that option yet, so I have to figure out how to avoid all this airtime. I will go to the base geometry and remove one of these corners. If I click apply again, you can see now that it only cuts the selected faces. These lines are movement from one side to the other, so there's no airtime when cutting, but the operation is still somehow not gonna work. You can see they're pretty short movements. Let's go back to the operation tab, change the cut pattern from line to offset. Click on apply again, and you will see that it will result in a much better solution, but we still have to adjust some parameters. I want this operation to remove most of the material. There are two things I need to change: the step over from 100 to 50% and uncheck the boundary reinforcement. Click on apply again, and now you can see that it removes most of the material in several passes, so everything should be fine, should be okay. Click on OK to close the operation. I still have this little corner here. For this I will select the 3D surface operation, click on this button, copy the operation in the job, double click on the newly created job, go to base geometry, remove all the other faces, select them, or maybe click clear, it's much easier. Select the face that it's still missing, click on add, click on apply, click on OK, and now you can see that the operation is complete. It will mill the entire beveled side of the inside of the tray. But I still want to make a very smooth finish. This will leave some very large steps and will require huge amounts of sanding. It's not what I want to do. I want to avoid sanding as much as possible. So let's first rename these two operations: surface roughing, the second one surface roughing remains. Let's copy the first operation, let's also copy the second one and rename them surface finishing and surface finishing remains. And now let's edit them to make them remove the material correctly. Double click on the surface finishing, go to the step over, modify it from 50% to 2%, a small value. So now, after pretty long time, took me around 1.5–2 minutes on my computer, you can see there are a lot of passes which will leave on almost perfect finish. So I can click OK to close this surface. But now I will do something in order to be able to work on this project in an acceptable manner. I will click on the disable button. This way, no matter what I change, there won't be any recomputation triggered for this operation, because otherwise any modification in the document that would trigger a recomputation would take 2 minutes or longer. I will do the same for these two operations because they also take some time. And now let's go to the final little piece, change the step over to 2, click on OK. This will leave an almost perfect finish. There's no need for additional sanding, just a light pass with a 300 grit and you will have a perfect surface. It will take a little bit longer on the CNC, but it's much easier to just wait and look at the machine than sanding by hand. Let's make these recessions for the inlay. Double click again on the job, go to tools, click on add. I will add the 3.175 millimeters. I will give it lower speeds of 1500 both on horizontal and vertical, and the spindle speed of 18,500 again. I set smaller speeds for this end mill because it prevents tear out on the small pieces, which will lead to some ugly results in the end. Click OK to close the job. Now hold Ctrl down and select all these faces, click on the pocket button, select the proper tool controller. I will change the pattern to zigzag offset again, the angle to 0 degrees, the step over to 50% to make sure there won't be any leftover material here. Check the use rest machining. As I've told you, this is a very useful tool because the part of the stock above this face was already milled, so checking the use rest machining will avoid remilling that surface again. Click on apply. You will see that it FreeCAD doesn't actually do that, and I will explain you in just a couple of moments why it doesn't leave that material unmilled. You can see that it mills the entire height of the recess in the tray, but it's a normal behavior. You can see that all the previous operations are disabled, which means nothing is cut. I have to enable the mill face, and after enabling it, right click on the pocket shape and recompute object. And after the recompute, you can see that most of the upper part cutting has been removed. It still has some bugs, it still considers some small pieces here, I don't know exactly why, uncut. So let's go the old way. I will disable the mill face again, double click on the pocket shape, and instead of use stressed machining, let's select this face, go to depth and click on the arrow next to start depth. Click on apply again, and you can see now that it will only mill below this surface, because as you remember, we have a mill face operation which will remove most of this material. Click on OK to close the pocket shape. Now select it and let's do a little trick to speed things up. You can see here the cycle time is 9 minutes 36 seconds, and below, just below, is keep tool down and min travel. Let's enable, let's set them to true. And now the cycle time has been reduced to 7 minutes and 7 seconds. So after cutting the inside of the inlay, let's cut the outside of the tray, and then we will flip it over to cut the handles. Let's disable this pocket shape too, and with the model selected, click on the profile button, click apply, change the tool controller. Remember that anytime that you create a new operation, the default tool controller will be the one in the previous operation. It's best practice to get used to always check the tool controller. You can see that I have this profile cut. You might have a vacuum table, so this can be done in a single operation. I don't have a vacuum table, I have to use clamps, so I will divide this profile operation into two parts. First I will cut these long edges, and then I will cut the ends of the tray, because the first time I will hold it down using clamps on these two sides, then I will switch the clamps on these two sides and cut the rest. So go to the base geometry, select the bottom line, which is kind of impossible because the bound box, the stock, is overlaying the model. I will click cancel, first select the two lines, holding Ctrl down, and then invoking the profile operation, change the tool controller again, click on apply, and nothing happens. This is a bug that is still there, but I have the solution to this bug. Go to the final depth, and instead of 0.00, the final depth of the operation, just write 0.02, and now magically the operation appears. Click on OK, select the profile operation, copy the operation in the job again, double click, go to the base geometry, click on clear, and now let's add the rest of our model. I won't be able to select the bottom line for this part where the handle is, so I will select the top part, and I have the same problem, but let's just add the corners, and I will show you how to add the rest of the model. I've selected the four corners, click on add, click on OK to close the operation, and because it's pretty difficult to select these two lines when the bound box lines are overlapping, I have to do a little trick. Just remember to undo what you do now, double click on the job, go to the extend and extend on the X, because I want to select the X now, click on OK, everything will recompute. Not everything will recompute, just the active operations. That's why I have disabled the surface finishing, roughing, and all the other operations. Otherwise, just modifying the bound box would have triggered a recompute of about 4 minutes. Now double click on the operation again, go to the base geometry, and as you can see, I can easily select the lines now. Click on add, go to the other line, click on add again, click on apply, and now the operation is complete. Click on OK, and don't forget to go back to the job and change the values from the extension of the X back to 0. You can also leave them to 1. They only influence your work in certain situations. In this situation, it wouldn't influence it at all. So now I have two separate operations which will result in a complete profile. I will run the first operation, move the clamps, run the second operation, and this will result in a final shape exactly as I want it, but using clamps to hold on the work. Now go to the tray base again, select it and create a new job. Make sure it is selected, click on OK. And for the handles I will use a 15.9 bull nose. I will give it a 2000 speed horizontal and vertical, a spindle of 18,500. I'm using lower speeds for the same reason. At the ends of the cut there might be some tear out, so I prefer to reduce the speed. Go to the setup again, go to the default values, change the clearance and the safe height. The tool diameter I won't change it now because I will change it in the operations, so you can see that you can also modify this from the operation. Click on OK, and I cannot mill this face from this position. So what I want to do is to go to the job, select the model, go to edit, placement, check the apply incremental changes and rotate it twice with 90 degrees around the y-axis. Now the model is rotated 180 degrees. Double click on the job, go to the setup and click on the refresh button. This will move the bound box back here. Click on the corner of the bound box after checking that all the extensions are set to 0, otherwise the origin will be wrongly placed. And after selecting the corner of the bound box, click on set origin. Now everything is set up okay. You can take the piece of wood, place it at the origin of the CNC, and the following operation will be exactly as it should be. The model that I have created has rounded corners. It looks very nice in the 3D view, but I will have some issues selecting the surfaces for the 3D operation. Here is that part when you simply end up hating FreeCAD, because you cannot mill these rounded pieces. It will result in an error in the normal pocket operation. In the 3D pocket operation it will also give you an error, so you have to rely to some little hacks. Go to the pockets that define these two handles, open the sketches and modify the radius of the roundover from 7.95 to 0.01 millimeters. Close the sketch, open the second one, also modify the radius to 0.01. I modify the radius because I don't want to simply remove the roundover and make the points coincident. It's much easier and easier to modify later. Well, after modifying the model you can see some pretty weird stuff here. That's because FreeCAD automatically made the model from the first job visible. Don't ask me why it does this. Also the stock is visible, I will hide it. Now let's go back to the second job, select the bottom, create a new pocket operation, change the pattern to offset, go to extensions, enable this edge so the cutter will be able to move, and now you can see that it will remove the material for the handles. If I don't enable the extensions, the cutter will try to stay inside this face, which it cannot do. It doesn't fit, and as you can see it will cut absolutely nothing. So enabling the extensions is crucial for this operation to work. When creating the job I didn't modify the step down. For this, to set it in the operation, I have to go to the depth tab, and here I have step down. I cannot modify the value from here, but I can edit the expression. Instead of op tool diameter I will click on clear, and now I will be able, even though it's still grayed out, I can write here anything that I want, 2 millimeters. Click on apply, you can see a lot of layers. This will result in a smooth finish. I also want to do the same thing for this end, and I can join them in a single operation. So select the face, click on add, go to the extensions again, because I also want to enable the extensions for this face. You can see it here highlighted in purple when selected. Click on apply, and now both handles are cut in the same operation. Even though the shape looks square, here you have to take into account the shape of the cutter head, which is a bullnose cutter head. It will leave a very nice roundover for all these edges, so the handles will look very nice in the end, even though now you have to rely to this hack to reduce the radius for the corner in order for this to work. Rename this second job handles. The first one will be called job tray. And now let's select the insert cutout, click on the create new job button, go to the tools, add the 3.175 millimeters end mill. I will give even smaller speeds of 1000 because the material for the insert is very brittle and I don't want to crack or to splinter. This still happens sometimes, but the lower speed and the stiffer the machine, of course, it will result in a better surface at the end. I also want to set a step down of 0.5 millimeters. Smaller steps always work better. Set the clearance and the safe of 35 and 33. I can now click OK. Let's hide the tray from the second job, also the stock. And now go to the third job. Let's rename it job insert. And we have to modify the model to rotate it to be correctly placed so we can mill it. You can see now it's facing downwards, it cannot be milled. So select it, go to edit, placement, apply incremental changes, rotate it twice around the y-axis. You can also rotate it around the x-axis and double click on the job, go to the setup tab, click on refresh, select the corner, click on set origin, and now everything is placed correctly and will be milled correctly. Click on OK to close the job. Let's remove the material to have these raised pieces to glue them in the tray. Select the face of the remaining material, select the new pocket operation, change the pattern to offset, change the step over to a 70% step over, click on apply, and now I have the G-code for milling the insert. I still have to modify those two values. Let's open the operations, the pocket shape, scroll down. Let's take a look. 48 minutes cycle time, it's a huge amount of time. Let's modify the min travel and the keep tool down. And we have reduced the cycle time to 30 minutes. It might still be too long. Depending on the material, you can use higher values for the step down or for the step over. I will change the step down from 0.5, make it 1 millimeter. Hope it doesn't splinter too much. And now the cycle time is 15 minutes, which is acceptable, but I still have a couple of issues here, and here. It won't cut these little parts. Let's open the pocket shape again, go to extensions, check enable extensions, and check this wire that has been generated. Click on apply, and now the entire model is cut correctly. Click on OK. After gluing the insert here, I will be left with a square, a rectangle above the surface of the tray. So I need to make an operation to remove that material, and I will use a little trick here. I will select all these faces, holding Ctrl down, make a mill face operation using the 15.9 bull nose, with a zigzag offset pattern and an angle of 0 degrees. A step over of 50 should do it. Click on apply, and you see the operation is not what I want, so I will have to go to the depth tab, and for the start depth I have the height of this surface, which is 13 millimeters, and I will add 5 because I was using an 8 millimeter stock for the insert. The 3 millimeters will go inside, so I will have 5 millimeters above this surface. So I have to go to the start depth, click on the expression and write 18 here, and also the end depth, because you can see now it goes all the way to the height of these faces, which I don't want. So I select this face and click on the arrow. Now it will mill from 18 millimeters to 13 millimeters, which is exactly what I want. But the piece of wood that I used for the inlay is much bigger than this, so I'll go to the operation, go to material allowance and write a value of 20 millimeters. Now the operation is exactly as it should be. Click on OK to close this. This will be the last operation that we will do on the tray. You have seen each of the operation in action after creating them. Now I export them, I go to the machine and make all the milling. I end up with this very nice tray after a little bit of sanding and of course applying the oil, leaving it to absorb, wiping and all the woodworking stuff that I'm not going to bother you with today. Thank you for watching. Don't forget to subscribe. Don't forget to visit my Patreon page, and if you are a subscriber you can download this file for free and see everything that I did here. So see you next time when we will make another project, another very interesting project using only open source software.